Namaskar aspirants, this is the continuation of our video series on motor design and its component. Let's start. Which of the general advantages listed does the electrical pyrometer have over the mechanical pyrometer? And the options are: when heated, it will move proportional to the amount the metal has lengthened or expanded. The pointer associated with the pyrometer scale can be made to also measure engine RPM. It can be utilized in exhaust manifolds and heat exchangers interchangeably. It can indicate temperature at a distant point from the source of the heat. And the correct answer should be: it can indicate temperature at a distant point from the source of the heat. Our next question is: in a large slow speed propulsion diesel engine, the force applied to the crosshead is, and the options are: against the crosshead during power stroke and away from the crosshead during compression stroke, against the crosshead during the compression stroke and away from the crosshead during the power stroke, against the crosshead during the power and compression stroke, away from crosshead during power and compression stroke. And the correct answer should be against the crosshead during the power and compression strokes. A diesel engine is driving an alternator required to run at 1800 rpm. The overspeed governor is normally required to be set within a range of, and the options are: 1980 to 2070 rpm, 2100 to 2200 rpm, 2200 to 2300 rpm, 2300 to 2400 rpm. Normally the set overspeed governor is 10 to 15% of the rated. So the correct answer should be 1980 to 2070 rpm. A crankshaft whose center of gravity coincides with its center line is said to be, and the options are, there are two options given, and from that two options there are four further options are given: statically balanced and dynamically balanced. And out of these two options, only one is correct, statically balanced, so the correct option should be one only. A 6-cylinder 2-stroke cycle single acting diesel engine has a 580 mm bore and 1700 mm stroke. What indicated power per cylinder will be developed if the average mean effective pressure is 15.3 kg per centimeter square at a speed of 120 rpm. This can be calculated by the formula P mean effective pressure into length of the stroke into area into rated into the rpm given divided by 60. From that calculation we will get 1348 something. Yes, 1348 kilowatt. You can calculate it in your copy or notebook. Using a diesel engine indicator PV diagram, the cylinder mean effective pressure is calculated to be 21.3 kg per centimeter square. What is the scale of the spring used on the indicator if the diagram area is 18.46 centimeter square with a length of 13 centimeter? Spring scale is mean effective pressure is equals to diagram area divided by the length of the diagram into spring constant or scale of the spring. By putting the value you will get 1.25. No, sorry, 1.25. I am not getting the correct answer. Wait, let me calculate it. 21.3 into length of the stroke 13, length of the diagram divided by area of the diagram 18.46. It is 1.5. The correct answer should be 1.5. Yes, this is the correct answer. My mistake, I did it in the calculation. Diesel engine valve spring functions to, and the options are: hold the valves open, keep the valves off their seats until the exhaust stroke is completed, close the valves, open inlet valves when the air injection cycle begins. The correct answer should be close the valves. The valve spring function is to close the valves. A built-up exhaust valve is one in which the stem and heads are made of different materials. The self-centering action comes from motion of the valve stem in the guide. A replaceable valve disc is welded to the head. Low alloy steel is used throughout. And the correct answer should be the stem and heads are made of different material. A 6-cylinder 2-stroke cycle diesel engine is 83% efficient and has a cylinder constant of 0.998 while operating with a mean effective pressure of 15 kg per centimeter square at a speed of 100 rpm. What is the metric brake horsepower developed? It can be calculated. Metric brake horsepower should be equals to the cylinder constant multiplied by mean effective pressure multiplied the rpm of the engine and then multiply it with the engine efficiency. You will get the mean metric brake horsepower. Now let's calculate it. 0.998 into 15 into 100 into 0.83, which will be equals to 1242.51. Then we have to multiply with the number of cylinder into 6, and this will be equals to 7455 kilowatt. A 7-cylinder 2-stroke cycle single acting diesel engine has a 750 mm bore and 200 mm stroke. What indicated power will be developed if the average mean effective pressure is 14.8 at a speed of 96 rpm? You can calculate it with the above formula of P mean effective pressure multiplied by length of the stroke into area of the bore, where diameter is given here, and you can calculate it pi by 4 into d square. Keep in mind to keep the unit same for all, else you will get a wrong result, wrong answer, and the answer after calculation will be 14,363 kilowatt. That's all for today. See you soon.